Welcome back to another video on object-oriented programming using C Sharp. And the topic for today is inheritance. In today's video, we will explore inheritance in C Sharp in a crystal clear and practical way. We will cover 7 powerful topics related to inheritance, right from the basics of base and derived classes to more advanced concepts like sealed classes and methods, and multi-level inheritance. Let's get started. Inheritance is a mechanism in C Sharp that allows one class to acquire the properties and behaviors from another class. It enables code reusability, establishes parent-child relationship between classes. How it works? The class that is inherited from is called a base class or parent class, and the class that inherits is called a derived class or a child class. Let's look at this example of a bank account base class, which has properties like account number and balance, and it has methods like deposit and withdraw. We have two child classes that is inheriting the base behavior and the base properties of the bank account class and implementing specific implementations like the savings account introduces a new property called as interest rate and introduces a new method called as apply interest. This way, a child class extends the behavior of the base class by inheriting, I repeat, inheriting all the properties and methods of the base class, thus promoting code reusability and modularity. Now let's jump to the code and have a look at the same example that we discussed. Bank account class with properties account number and balance and methods deposit and withdraw. We need to make a note that we have made use of virtual keyword for the method withdraw, which means that any class that inherits bank account class will be able to give a more specific implementation for the withdraw behavior. Savings account class inherits the bank account class, inheriting all of its properties and methods, and extends its behavior by giving a specific implementation for apply interest and also an interest rate property. When we create an object of the savings account class, we can see that we can make use of the account number property and the deposit method, which is a part of the bank account base class, and also interest rate and apply interest, which is property and method of the savings account class itself. Checking account class also inherits bank account class by inheriting all the properties and methods of the bank account class and extends the behavior by adding a more specific implementation for withdraw method. We make use of virtual keyword in the base class for us to be able to do this. And in the child class, we make use of override keyword to override the base behavior from the bank account class and to give a more specific implementation for withdrawal. In this case, it's going to be a validation for balance plus overdraft limit, which overrides the base behavior of the bank account class, which just checks for balance. Now let's run this example. Initially, we are calling savings account class with deposit and apply interest methods. We can see the output for the deposit and apply interest for the savings account class. And in the checking account, we deposit 500 and the extended behavior that was added using overriding in the checking account class was overdraft facility. We can see that with a deposit of 500 and a withdraw of 900, the overdraft has worked and it shows. Next, let's jump into the base keyword. The base keyword gives you access to the base class constructor or methods inside a derived class. It's useful when you want to reuse or extend the functionality of the base class rather than overriding the functionality in your base class. We had an example of how overriding works in the previous code that we saw. Now let's look at a code example of how to make use of the base keyword in your derived class to access the base class constructor or methods. Let's get started. Vehicle class, which has properties like make, model, and year, and it has a parameterized constructor, which takes in these properties, make, model, and year, and assigns it to the local properties. We have a start and stop method as part of the vehicle class. We have a car class that implements the vehicle class, and even the car has a parameterized constructor which takes make, model, year, and number of doors. And the point that we need to observe is it makes use of this base keyword as part of the constructor. It passes the parameters that comes to the car class. Those parameters are passed to the base class constructor when it initializes, when the object of the car is created. First, the constructor of the base class, that is the vehicle class constructor, will be invoked, and make, model, and year values will be passed. And once the parent object is constructed, only then the car object will start getting constructed. So if you see the sequence in which the console.writeLine here will be invoked would be, we will first see vehicle created, and then we will see car created with number of doors. So that is the sequence. In case of a static class, the sequence is different. The constructor of the child class will be invoked first, all the way backwards towards the parent class. But in a normal class, when we use a base keyword to invoke the base class constructor, always the base class constructor will be invoked first before the child class constructor even starts. So in the same way, we have a motorcycle class, which takes in make, model, year, and has a sidecar, which is a specific property for motorcycle class. Motorcycle class also makes use of the base keyword to pass on these values to the parameterized constructor of the base class. Using the base keyword, these values are passed to the base class, and even here, the base class, that is vehicle class constructor, will be called first, and after the vehicle object is constructed, only then the motorcycle class constructor starts. So even here, if we look at the sequence, it is going to be vehicle created with make, model, and year, and then you will see motorcycle created, sidecar, and has sidecar. So that will be the sequence. Let us see how we have called this in the program class. We create a car object. We call the start and open trunk method. Let's look at the car. We have a start and open trunk method. And here again, we are seeing an example of override. If, when we look at the base class, we see that both start and stop are marked as virtual, which means that the vehicle base class allows these two methods, which is start and stop, to be overridden in the base class. We mark that using the keyword virtual, and in our derived class, we make use of the override keyword to give a more specific implementation. That's the use case where the override will be used. There is no point in overriding if you're not giving a more specific implementation. In case of the car class, we can see the car starts with a key or push button. This is a specific behavior of the car class. Thus, we make use of the override keyword to give a more specific implementation for the start. In the same way, we see motorcycle, we use the override keyword to override the start behavior of the vehicle base class, because here we are giving a more specific motorcycle specific implementation. The console.writeLine that you see here is just for learning purpose. In case of a real world example, we will have more specific implementation for start here. This is just a boilerplate code. And coming to motorcycle, the way it is called in the program.cs, we create a motorcycle object. We call the start method and pop wheelie. So in case of the car as well as the motorcycle object here, when we call start, since we have used the override keyword to override, and give a specific implementation, this call will call the derived class implementation and not the start of the base class, because we have used override, and this is a child class object. Calling a start on a child class object will invoke the child class implementation. This is basically a form of polymorphism. We will look at this in more detail when we learn about polymorphism. Now let us see when we run this example. We were expecting to see vehicle created first and then car created. So in the same way, even for motorcycle, we see vehicle created and then we see motorcycle created. So the sequence that we discussed, we can see that in action here, and the output is as expected. Now let's get started with method hiding with new keyword. Sometimes derived class needs a method with the same name as the base class, but doesn't want to override it. In that case, we make use of the new keyword to hide the base class method and to provide a new implementation in the child class. Let's look at it with an example. We have a base class employee that has a method get salary details. And then we have a child class manager that also has a method get salary details. But instead of overriding it, it hides the base class method using the new keyword. So this is basically used when we have a restriction like we have a legacy code constraint we do not want to override. We want to define a new method for the managers. This is generally when we make use of method hiding. We need to use this with a caution. Method hiding should be used only when necessary, and typically overriding is preferred over hiding when using polymorphism intentionally. So, in case of an example like how I said, we have a legacy code constraint that we don't want to override. We want to define a new method, then we can make use of method hiding. So this is an example of method hiding. Let's see how it is called. When we create the base class object, that is the employee object, and we call get salary details, it invokes the get salary details of the employee since it's an employee class object. When we create manager class object and we call the get salary details, it calls the manager class the method hiding implementation. It calls the get salary details of the manager class. Now, when we create a employee referenced object, so when we create an object of employee type and we assign a manager object to it, though it is a manager object, it will call the implementation of the base class. That is something that we need to keep in mind. Now, let's run this and see the output. As we expected, the first call goes to the base class since it's an employee class object. And then when we create a manager class object and we call get salary details, it calls the implementation that we gave using the new keyword in which the base class implementation is hidden. It calls the manager class implementation of get salary details. And then when we create employee referenced manager class object, though it is a manager class object that is assigned, it will call the base class implementation of the get salary details. Let's jump on to the next topic. Now let's look at sealed classes and methods. Sealed classes prevents anyone from extending this class and changing its behavior in case of any security reasons wherein we don't want this class to be inherited and a new implementation being added on to the class. We seal the class using the sealed keyword, thus ensuring that it cannot be inherited. And coming to sealed methods, even if the class were not sealed, this prevents the specific method that is marked as sealed from being overridden again, thus ensuring the business rules are preserved. Let's look at this with an example. In a banking application where certain behaviors should not be overridden for security and stability reason, we have a bank account class with withdraw and deposit method, both marked as virtual, which allows the child class to give a more specific implementation using the override keyword. We can see that we have a fixed deposit account class which inherits the bank account class and gives a more specific implementation for withdraw using the override keyword. It also marks the withdraw method has sealed because we don't want this method to be overridden further down in any class that inherits fixed deposit account. And also the fixed deposit account class is marked as a sealed class because no further inheritance has to be allowed for fixed deposit account. This is the use of the sealed keyword for be it a class or a method, wherein for any security reasons we don't want any further implementations to be done for the fixed deposit class or the withdraw method. We make use of the sealed keyword to seal it from further implementations, further overrides. Let's see how this is consumed. When we run this example, we can see that when we create an object of a bank account class, when we call withdraw, it calls the withdraw implementation of the base class. And when a bank account reference with a fixed deposit account object is created, and when we call withdraw, it calls the withdraw implementation of the fixed deposit account. But there won't be any further inheritance of the fixed deposit account. If we have a class which tries to inherit the fixed deposit account class, it will result in an error. And even if the fixed deposit account class was not a sealed class, even if the derived class of the fixed deposit account would have tried to give implementation for withdraw, if it tried to override, it would have resulted in an error. Now let's get started with abstract classes and abstract members. An abstract class is like a blueprint, or to be precise, something like an incomplete instruction manual. It can't be used directly, which means that it can't be instantiated directly, but it lays the foundation for other classes. With the abstract members declared in it, it enforces the child class to give an implementation for those abstract declared members. Let's look at it with an example. Let's look at this example of a shape abstract base class with a color property and a draw abstract method. Rectangle and circle, both classes inheriting shape, overrides and gives implementation for the abstract declared member draw. So rectangle and circle give their own implementation. And we can see by creating their respective object, a shape reference rectangle and a shape reference circle object, we will be able to call those specific implementations that were given by circle and rectangle. Abstract class behaves as a foundation for other classes. It is incomplete because it has abstract methods. Since it is incomplete, it cannot be instantiated. We also Let's get started with constructor inheritance. Constructors aren't inherited, but a derived class can explicitly call a base class constructor using a base keyword. Why it matters? Base class might require parameters to initialize essential properties. So a child class is expected to explicitly call the base class constructor using the base keyword and pass the parameter that the constructor needs in the base class. Let's look at this with an example. In this example, we have a vehicle base class, which has a parameterized constructor vehicle with one parameter brand, a car class that inherits the vehicle class, and also has a parameterized constructor with two parameters brand and model. As part of the construction, it calls explicitly the base class constructor and passes the parameter brand that is required for its construction. When a new car object is created, first the vehicle constructor is invoked with the parameter Toyota, and then the car constructor completes with the parameter Camry. Let's run this example and see how it works. Vehicle construction is called first, as that is the sequence when a child class invokes the base class constructor explicitly using the base keyword. The sequence would be the child class constructor will come after the base class. So the base class constructor will be invoked first, and then the child class constructor will be invoked. So we can see the sequence: vehicle construction called brand Toyota, which is basically the base class constructor kicking in, and then the car constructor called model Camry, which is the second parameter, which is the constructor of the child class. Now let's get started with multi-level inheritance. This is a scenario where a class is derived from a class that is already derived from another class. In simple terms, class A is a base class, class B inherits from class A, and class C in turn inherits from class B. Multi-level inheritance is a type of inheritance where a class is derived from a derived class, forming a chain of inheritance. Let's look at this with an example. In this example, we will see a three-level multi-level inheritance, starting with a person base class with properties name and age, with a method introduce which prints a self-introduction. This class models a general person, and then an employee class which inherits the person and adds additional properties like employee ID and department, with a method work which describes the employee's work. And then comes the third level, a manager class which inherits from the employee class, adding additional property of team size and additional method conduct meeting, which describes a manager leading a team meeting, which is an additional behavior on top of the first two levels. Coming to the program class, we see it constructs a manager object and initializes it with specific values. The manager object uses methods from all three levels of the hierarchy: introduce from person, work from employee, and conduct meeting from manager. Let's run this example. We can see that it invokes the respective method from all three levels of inheritance. Thank you for watching our video. Do subscribe our channel for more such videos, and thank you for your support.